Hey, so I said I would get some specs on this 540 build, uh, logged at least. It helps me even have it on video because between the various laptops and pieces of hardware I've had and moves, it'd be nice to have this at least captured in a video online as well as saving the video on my server here at the house. My cloud, as they say. So the builder had helped me with a few items, not the builder, but the machinist, when we were putting together the short block. And one of the first things that we changed was the cam. I had bought a crane cam, but we'd wound up going with a Howard's cam. The specs on it, just get to the specs. The specs on it, clearance, hot on the intake was 024. The clearance hot on the exhaust is 024. It's 110 lobe center. Um, it's a 692 lift on the intake and a 692 lift on the exhaust. Duration on the intake is 296. Duration on the exhaust is 306. So you can kind of see the specs on the cam. So that was the cam, and it is a roller. It's not a hydraulic. It's a roller, and so I look forward to getting that rolling at some point in time. The degrees of duration at .050 is 258 on the intake and 268 on the exhaust. So that, okay. So just some of the basics. I'm just going through some of my papers here. So just some of the basics on the motor. Cubic inches is a 540. It's 537.6 cubic inches, which is compared to factory, the OE side of it was 460. So it's an increase of 77.6 inches. The bore is 4.5 as compared to the 460, which is 4.36. The stroke is 4.225 as compared to the 460, which is 3.850. Rod length is 6.8. And I'll tell you here in a little bit, there's a little bit of difference to that. And I'll talk about the rods. The rod ratio was 1.61. Compression is per the theoretical build was 10.5 as compared to 8.5 on this block. But it's actually a little bit higher than that, given some of the milling and things that were done. The rockers are 1.73. I got those. They're a Schneider. Talk about those in a second. The intake valves are 2.25. The exhaust valves are 1.76. For the 460, 2.08 and 1.65 respectively. So the horsepower, and this was using machined OEM heads, 714 horse at 6,000 RPM with 684 foot-pounds of torque at 4,500. but it's going to do more than that because the cam is altered from what the design build was to be, and the Super Cobra Jet heads versus the machining factory heads. So that's a bit on the general summary of the specs on the motor. So the crank. So actually, it's a nice. The crank that's in there is the crank from the Marine motor. It's a good crank. So we had it Magnaflux, D-Bird. It was offset ground to 2.1222, and that increased the stroke from 3.85 to 4.225. There were chamfered rod oil holes. There was a V-slot ground on the main journals. Kind of creates a scoop, if you will, for oil, and pressure feeds the rod bearings. So in micropolish, all journals to 2.1220. So that was it on the crank. So the block is a 460, 90 from 96. I've actually have a pamphlet of all the specifications for the Marine blocks from the Lima, Ohio plant from Ford. One of their engineers sent it to me. So if there's anybody looking for Marine specific data on an entire functioning assembly from pan to carburetor, that's what the two motors were that I bought, were in crates. They were complete assemblies. But I've got the Lima plant's engineering specifications for the motors. Sonic checked, bore honed to 4.5, which is 0.14 over stock. Minimum of 0.125 on the thrust sides. You can go to a 0.080 and still be safe, because it's pretty nice motor. It's got a lot of material in there. Cut the deck. The deck was cut to 10.31, 10.315, somewhere in there. Had all the drain back holes deburred, the casting defects in the lifter gallery taken care of. The block was cleaned and all that good stuff. Okay, so the rods in this thing, connecting rods, believe it or not, they are out of a 240 Ford 6-cylinder. And they have a 6.795 inch length, but they're a 6415 steel. So they're strong as crap. They're lightweight, and they provide the applicable stroke with the offset grind. And so they were reconditioned, and it's got a .990 pin in it. And then there was a .125 inch hole drilled into the pin end for pin oiling. So nice rods for very economical cost, and they're strong as shit. So you can spend a lot of money on H beams and so on and so forth. But if you're doing a stroker, just those 246 Ford 246 cylinder rods are awesome. But I'll tell you what, they're getting hard to find. So good luck on that. I found mine out in California somewhere. So the heads, had the heads done, had them flowed, and so that's the flow data on the heads. So at valve lift at 0.1, the intake was 73.7. At 0.2, it was 148.8. At 0.3 inch, it was 223.4. On the exhaust, it was 135.9. Jumped down to at a half inch. The intake side was 327.8 and 222.5 on the exhaust. Go down to 7 inches, which is pretty much 6.92, which is pretty much the full lift. They flowed at 346.6 on the intake side and 256.9 on the exhaust side. So those cover jets do flow fairly nice. Talk a little bit about the heads here in a second. So the rockers, they're a stainless rocker, Schneider racing cams. It's a 173 by 7/16 inch stainless rocker, and Schneider. So they're a fairly decent piece of equipment. Okay, so the valves. The valves are from Racing Engine Valves in Fort Lauderdale. And it's a 2.250 on the intake. And it's a 1.750 on the exhaust. They're both 11/32, and the intake is by 5.3 inches in length, and on the exhaust it's 5.065. So fairly good sized valves. I mean, they're certainly bigger valves out there on heads, but for my purposes, I think that'll be just fine. So the pistons are a Venolia racing piston, 4.5 pin oilers with a .990 pin, and there was skirt milling done, and those pistons assemblies were all balanced. Again, this motor is internally balanced. The pistons and stuff were balanced out. So I don't think there's much more than the cam is degreed at 106. The main bearings came in at a minimum of .0027. The max was .0028. The rod bearings .0024 to .0025. And the crank end play came in at .006. The ring gap on the top piston was .020. Ring gap on the second came in at .015, and the oil ring came in at .028, which was a hair above the minimum, which should be .020. So that is that. Now I mentioned I have a complete specification on these motors. So this pamphlet here, which contains all the core data for that marine motor. And when I say that, I mean this thing has details about the build of those motors. That was out of the Lima Ford plant. It's got the curves, just all kinds of the engineering detailed information. So a lot of that is moot since I changed it all, but these were for those. The 460 is the marine application, and marine or industrial. So you can see, I probably shouldn't have got this, but I got controlled copies from the engineers out there on these 7.5 liter marine and industrial motors. So I like that. That's kind of cool information to have hold of. So that's the details a bit on that 540. So tonight, as I watch, I guess it's the second race of NHRA tonight, I'll watch it and get online to see about ordering some headers, or at least doing some research on headers for that thing. Figure it out, because the headers in the oil pan, and I'll be able to start buttoning that motor up rather than just mocking it up, and get going on the car itself. So anyway, that is all I've got to say about that. And I'll post up another video here on the build probably in another day or two. And I've got to go drop my Shelby off tomorrow for a recall on the airbag. And I'll have the Ford house go ahead and change the oil. And so I'll probably be a little bit busy tomorrow, next couple of days. But I'll get something posted again as I continue on with this project.